So today we are also going to do an exercise. I mean that is only for a small amount of the time, but still there is an announcement for tomorrow because tomorrow class will be starting at 9 o'clock in the morning. So I request you all to be present in that class because that is class is important. Like it's
आणि ना
some.
मॅडम त्यांनी मी सांगतेय की तुमचे बरोबर विद्यार्थी काढले होते मॅडम.
Can you please turn off your mic? I request you to please turn off your mic. Okay. So in between what we can do, we can take a snapshot. So I request if someone can open their cameras, if possible, they can open their cameras and I can take the snapshot. Okay, thank you, everyone. So okay, we will start. Okay, I hope my PPT is visible. Okay, thank you. So today's topic is MQTT, and believe me, this MQTT is very much important and an essential part of IoT communication. So whenever you are sending the data for IoT, you require a protocol or a mechanism such that it is suited for the IoT. So first we'll go through what is MQTT, and then most importantly why we need MQTT, and then we compare HTTP versus MQTT because HTTP is widely used when we talk about the internet communication, like internet or when you are browsing any of the stuff, right? Then we talk about the model of the MQTT and then how a MQTT connection established, and after that we'll try to have a small example, right? And we will be trying to demonstrate it. Okay, so now what is MQTT? So MQTT is a very lightweight protocol, and it is specifically designed such that it can work in a constrained scenario, like where the processing power is small, where the battery power requirement is small, something like that. is there, I mean, when there is a constraint environment in terms of computational power as well as the battery power, uh, and the processing capability is very much limited. If you remember our previous classes, there always we talks about the IoT nodes have limited power resource, and they have also limited processing capabilities, right? So therefore, in the initial, when we assume that our IoT is having low power and low processing ability, right? So we need to develop a protocol such that it can work with these two constraint environment, and therefore there is MQTT. Now the model of the MQTT, or it is based on a publish and subscribe architecture, right? I'll tell you what is the publish and subscribe architecture and what are the advantages, right? So of course it has many advantages over other protocols, like I'm talking about the HTTP. Why I always going to compare throughout the class to the HTTP, because HTTP is widely used. That's why I'm going to compare with that only, right? And more importantly, MQTT is not message queuing telemetry transport. Believe me, it is not. Because initially when name came into the picture, people are having confusion that MQTT is message queuing telemetry transport. No, it is telemetry transport. Okay, now you can ask what is MQ. Look, actually this is developed by IBM. So when at the developing phase, they have a series called MQ, and then when have they have developed, they named it MQTT, right? So people usually confused with this MQTT, right? So no need to confuse it. Message queuing telemetry transport. There is slight differences also, right? This is the definition for MQTT. So I'll read it for you. I have directly copied from MQTT 3.1.1 release. That's why I have quoted also. So it says that MQTT is a client server publish subscribe messaging transport protocol. Just see, it is a client server publish subscribe messaging protocol. So just see, it has two terms: client server and publish and subscribe, right? So we'll when we really do that experiment, we will see what is the significance of client server and publish and subscribe. Again, it says that it is lightweight, open, simple, easy to implement. So we'll also see how easy it is to for the implementation. These characteristics make it ideal for use in many situations, including constraint environment, as we have already talked about when on the first point itself. It's including the constraint environment such as for the communication in machine to machine, Internet of Things, right? So whole motto when it was going, when IBM was designing this protocol, the whole motto of this protocol is it can work in a constraint environment, and the constraint environment is low power, low processing capability, right? And also I mean, it requires a very small code footprint that we will see in the next slide. So now to focus is what is MQTT? The MQTT is a publish subscribe protocol. So what we try to or what you need to need to know is it's a publish subscribe protocol, and it is very lightweight, right? So why it is called lightweight? Because when the headers of this protocol are having this protocol is having very small headers, right? So when you're trying to send the actual data, you add some of the headers and then you send it, right? So for this protocol, the headers are quite small. Therefore, we require a small data rate. If you remember the previous class, there we also talks about that this IoT has a limitation of small data rate, and this limitation we have we had deliberately designed, right? So these things we need to remember, that it is a publish subscribe protocol. It is very much lightweight, and it is therefore it is also suited for small data rate applications, right? Like IoT, machine to machine communication. If you have any question up till this point. Okay, thank you. Now we'll talk about why we need MQTT. Okay, need of MQTT. A part of this we have covered in the previous slide itself. Okay, so to answer this question, the IoT is having different challenges. Like if you compare with HTTP is whole. I mean, they are very much different, because uh, when we are using HTTP, we have a lot of computation power and lot of battery power, right? But when you compare this IoT with conventional use like HTTP, IoT has altogether different applications, and therefore we need to have a different protocol. And when we are choosing a protocol, I'm not only saying MQTT is the only protocol, not only. We also have COAP. That way I'm not going to discuss. I'm only going to discuss about MQTT because it is very much famous and widely used. So I'm not only saying that MQTT is the only protocol for IoT. I'm just saying MQTT is the one of the protocol for IoT. Now, when you are designing any protocol for IoT, you must consider the following points. Point number one, that the information generated by IoT or the one source can be transported to many. Like suppose in the case, if you are having a physical condition, like let us say we want to measure the temperature of any area in Pune. Let us say we want to measure the temperature of Vimannagar. That is one of the uh, uh, Pune's part. So I will place some of the sensors, right? And I can also temperature sensors. I can also place some gas sensors to measure the pollution of that. And those data I can send to anyone. Like someone is only interested about the temperature, someone is interested about the pollution value, and then they will compute for themselves, and then they come with the idea that we can do something like this to reduce the pollution, right? So the first point is information generated by one source can be transported to many. That is the first requirement. So when you're designing any protocol for IoT, you need to have the first requirement. The second requirement is whenever you generate the data, uh, it must be collected, right? The third is generation of huge volume of data in small packets. So what do we mean by this? Okay, so as we are aware of, uh, there are sensors, right, which generate a small amount of data, right? And if there are a lot of sensors, so the volume of the data will be huge, and this volume consists of a small amount of data from the sensors, right? And the most importantly, the last part is when you are sending the data, mostly you have the unreliable networks, because even when you talk of deploying uh, your IoT, you generally deploy in the remote locations, right? So there may be the unreliability in the connections. Okay, these are the four important points. Beside these four important points, we have also some of the points, right? And some of the points of the volume of the data we have already talked about, right? Volume of the data we have already talked about, yes. The power consumption we have not talked about, right? So as we already know, low power consumption is our requirement. The third part is real-time delivery, right? So whenever you generate the data, it must be transferred to your system or the person which is or absorbing. Fragile connection, we have already talked about the unreliable connection. This part is the privacy and security. As we are aware of that IoT are also deployed in these scenarios where we also have the private data, right? I'll tomorrow class I'll talk about why your how your private data can be exploited, right? And last part is scalability. So scalability is also one of the important parameter when you are going to design any protocol for IoT, right? So therefore, keeping all those above 4 point and below 6 point, the IBM have developed MQTT. I request you to switch off your microphone. I think someone microphone is on. I request you to please switch off your microphone. Okay, thank you. Okay. Next point, I'm going to compare between MQTT and HTTP. Right? So first point, we'll talk in terms of modeling. So the MQTT is designed, as I told you, on the base of, I hope my PPT is visible. Okay. So MQTT is designed on the model of publish and subscribe, while the HTTP is designed a request and response. I'm not going to tell you what is HTTP? I believe that you all are aware of HTTP. There, what you do, you request through the browser, and the browser access to the server. There is a request from browser to the server. If there is data on the server of the particular request, then the server respond to the browser with that particular data. So this is the working principle of HTTP. But still, I believe that everyone is aware of HTTP, right? So first point is the modeling. So modeling, it is based on the publish subscribe architecture, right? But while HTTP is based on request and response. Look, the MQTT is designed to be data centric, while the HTTP is designed to be document centric. And why it is designed to be data centric? Because it is specifically designed to focus on the IoT communication, right? So that's why it is designed on a data centric, right? The speed of MQTT is, you can see on the slide, that is 93 times higher than HTTP, right? MQTT has 3 quality service levels, while HTTP there is no quality of service level. The frame size is small. It is nearly 67 kilobytes, while it is large in the case of HTTP, around 356 kilobyte, I guess. Header size is very small, because as I told you, when you talk about this, the small a smaller frame, so you always have the smaller header size. The complexity of MQTT is very much simple. I mean, it is very simple, while the HTTP is complex. Bandwidth requirement is low. Why bandwidth requirement is low? Because it is suited for low data rate communication, right? While in case of HTTP, the bandwidth requirement is high. Latency is very much low in case of MQTT, while latency is high in case of HTTP. And if number of users increased, latency become very high. So that we need to focus. Throughput uh, is high in case of MQTT, because it has a small size of header size. Data type, it supports raw binary data, but while in the case of HTTP, it must be base64 encoded. And we have already covered this point. Power requirement. So power requirement is very low when we talk about the MQTT, and it is high in when we talk about the HTTP. Now we will discuss the model of MQTT. Up till now, what we have discussed, what is MQTT, right? What is MQTT? How, why there is a need of MQTT, right? Because already there are very much, I mean, a lot of protocols are already there, which are working very fine with the internet world, right? So why we need that? So we have already seen that. Next, we have compared some of the characteristic of MQTT to HTTP, right? Now we are going to dive into the actual model of MQTT, right? So just see, as the definition, the first point is the definition only. It works on the publish subscribe model, and it is different from the client server model, that is more specifically, I'll say a request response model. That HTTP. In client server or request response model, a client is always connected to the end server. but it is not in the case of MQTT or the pub sub model. Sometimes it is also called pub sub model. So not in the case of pub sub model, because in the publish and subscribe model, it is not necessarily that the client is always connected to the server, right? So it is not that client is always connected to the server. It Sometimes it happens that the client never, the sender never talks to the receiver. In the publish subscribe model, we'll see how it is possible, right? So as I told you, what happened in publish subscribe model, a client generate a message, and the client who generate a message is known as the publisher. So I'll write over here, publisher who generates the message. So a client who generates the message, right, decouples from the client who received the message, and that is known as the subscriber. Okay. So here, sorry, here there are two clients. One is known as the publisher, one is known as the subscriber, and as this point suggests, they both are decouples from each other. That means they does not really contact to each other, right? So they does not really contact to each other. So there are two terms, publisher and the subscriber. Publisher is, that means, who generate the message, and subscriber who receive the message. I'll take you I'll give you a small example for this, right? So in many, in the most of the part of world, what we do, we have a newspaper subscription, right? So in case of newspaper subscription, what happens, the news vendor, the paper vendor, is having a lot of newspaper. Let us say Times of India, Hindustan Times, and there are many. I'm not naming one, only one of them. Maybe Navbharat Times, Indian Express, something like that, or and the Hindu also, like. So what happened, these are the publisher, these newspapers are the publisher, and here let us say there are subscriber 1, 2, 3, 4, 5, right? This publisher, let us see, this publisher does not know who is purchasing our paper, right? Like suppose what they deliver these papers to the news vendor, right? What they do, they deliver this paper to new. Okay, I'll let me share my whiteboard. That will be good for me also. Okay, so how it works. So as I told you, we have Hindu paper, we have Indian Express, we have Times of India, Hindustan Times, Navbharat Times, and maybe, I only know these papers, but there are many. In Pune, you can find Lokmat also. Right? So what they are the publisher, right? And here there is a newspaper vendor, and here we are a receiver, like say receiver 1, 2, sorry, 2, 3, 4. So what happened? These are the publisher, and these are the subscriber, right? So they send their newspaper to this news vendor, right? And they does not aware, these publisher are does not aware that who is reading our paper. It might be the case that they are aware how many are readers, right? Now this vendor takes all of the newspaper and distribute those newspaper accordingly, like uh, subscriber number 1, subscriber number 2, subscriber number 3 and 4. So let us say subscriber number 1 has subscribed Hindu as well as Navara Times. So what this vendor will do, it will deliver Hindu and Navara Times to subscriber 1. Then subscriber 2 only subscribe to Hindustan Times, so it will be, the vendor will deliver Hindustan Times. Next, it will be suppose 3 have subscriber Times of India and Indian Express. It will be delivered, and this has subscribed Lokman, so it will be delivered. Now, this subscriber are not aware of how they are getting the papers, right? And this publisher are not aware of who exactly is reading our newspaper. So this is the same model the same model is for MQTT, right? So MQTT itself, the publisher as well as subscriber, most of the time they don't know each other. And this newspaper vendor is also present over there, and it is known as broker. So the MQTT structure is like, we have publisher, we have broker, and we have subscriber, right? So this is the model of MQTT. If you have any doubt up till this point, please ask. Okay, I hope no. Okay. Now we have covered 2 points. Now this third point, as I already told you, most of the time the publisher as well as the subscriber never contact to each other, and in fact in most of the time they does not aware of that, right? As I told you, the 4th point already I have discussed is the connection between the publisher and subscriber is managed by the third part, and that is known as the broker, like the news vendor. So what happened? The broker collect all those data from the publisher, filter it. Filtering, like what happens in the case of the newspaper, the vendor filter which subscriber had subscribed the which newspapers, right? Like Hindustan Times or the Hindu, like, so it performs the filtering operation and then distribute it. So we'll talk of, okay, so we'll talk of the working of or the responsibility of a broker. So broker have three main responsibility: collecting the data, filtering the data, distributing the data. So broker has three responsibility: collecting the data from the publisher, filtering it, and then distributing it to subscriber. Next, we will see a model of MQTT. So just see. So what happened? A particular physical condition, we are assumed to be measure the particular physical condition. So what we do, we have deployed four sensors. Just see, we have deployed over here four sensors. So P1, P2, P3, P4 are the publisher. So what happened? P1 generates the temperature data, P2 generates the pressure data, P3 generates the light data, and P4 generates the moisture data. Now, what happened? They will generate the data and they will send to the broker. Right? They will generate the data and they will send to the broker. Now, what happened? There are more than there are seven subscriber, and that means that the subscriber numbers are greater than the publisher, and it may happen both ways. It may be the case where publishers are more and sorry subscriber are less. It may happen the case, right? So what happens? They will generate the data and then will send to the broker. Now up till the subscriber, that what kind of the data it subscribe. Like subscriber number one, that is S1, have subscribed all those four data, right? It subscribe temperature data, it subscribe pressure data, light data, and the moisture data. There is a subscriber number two. Just see, there is subscriber number two which either not subscribed any data or any topic. Okay, one thing I missed it. Okay, these terms, temperature, pressure, light, and moisture, they are known as topics. So a publisher generates a topic, right? So it generates a topic and send to the broker. Now S2, just see, S2 have not subscribed any of these topic, right? So the broker will not send any of these data to S2 because S2 have not subscribed any topic. S1 has subscribed all those four topics. S3 has only subscribed the light data as well as the moisture data. S3, just see. You can also decode with the color, right? So S3 has only subscribed two data, sorry, not three, two data. S4 has only subscribed the temperature data. S5 have subscribed the temperature as well as the moisture data. And S6 and S7 both having a subscription of light data and the pressure data. Right. So what this broker does, it has all those data, right? It filter it. I'll tell you how it filter it, and then sends to the subscriber. This is the working model of any MQTT scenario, or a scenario where MQTT works very fine, right? So I hope there is no question. If there is a question, please ask me. I hope there is no question. Okay, thank you. One of the term when we were talking about the MQTT protocol, there we talks about the publisher and the subscriber decouple each other. So what are the types of decoupling, right? So the first type is space decoupling, right? So the publisher and subscriber mostly they don't know each other in terms of port number or the IP address, right? The second decoupling is time decoupling, right? So it does not mean that when a publisher publish the data will be at the same time accessed by the subscriber, right? So what happened, if there is a broker, there is a subscriber, and there is a there is a publisher and there is a subscriber, right? So many times it happens when it generates the data is stored by this broker, and then it will be sent to the subscriber. So it does not mean they must be time synchronize each other. The publisher as well as the subscriber need not to be synchronized with each other in terms of time, right? So sorry, this was the synchronization decoupling. I'll tell you the time decoupling. Time decoupling means both are not required to be active at the same time, right? It may happens that a subscriber is sleeping or in the sleep mode, right? Or sometimes the publisher can also go to the sleep mode. So what happens, a publisher publish the data and send to the broker and went to sleep, and at the same time if a subscriber is not active, the data will be stored by this broker, and then the subscriber, when the subscriber wake up, it will collect data from the broker, right? One of the major factors we talk about the scalability, right? So scalability is one of the major challenge in the previous HTTP, because what happens when there are a lot of number of user in case of HTTP, right? And the user requests the same data from the same server, it becomes slow, right? So scalability is another domain where MQTT excels about the client server model, that is request response model. I'm talking about this is HTTP model, and this is possible due to the fact that the broker can perform various parallel operations, right? And that is the only reason the scalability is feasible. It may happen that there is a requirement of more than one broker. Sorry. It may happen there is a requirement of more than one broker. The example will be, suppose there is a large portion of a city where there is a portion of the city where initially there were few subscriber of newspaper, but eventually the subscription of newspaper become large, so there might be required two vendor to deliver all those newspaper in time, right? As I told you, filtering is the one of the operation performed by the broker, right? So we'll see what kind of the filtering it performs. So first of all, how it performs. So what it does, it takes the sorry, it receives the message from subscriber then it filter it, and then it's distribute it, or okay. Right. Now we'll see what are the kind of filtering. So there are three kind of the filtering, right? The first one is them is subject based filtering. Right? So we'll see what is a subject based filtering, right? So as I told you in the beginning that all of the message contains a topic, like in the previous case temperature was a topic, moisture was a topic, light was a topic, right? So they all the message comes with a topic. So what happened, the broker filters the message with the topic, right? And then the broker forward all those messages which contains the same topic, right? Like say temperature temperature is there. So whatever the message which is come through a topic name of temperature will be forwarded to the subscriber who has subscribed a topic of temperature, right? So this is the subject based filtering, where the filtering is done on the basis of a topic name, right? The second type of filtering is content based filtering. So what happened in this content based filtering is done on the basis of the content of the message. So the broker sees that what is the content of the message and look that what are the contents that subscriber have subscribed. So if the subscriber have subscribed the same content, it will deliver the message which is matching with the content of the subscription, right? But there is a problem with content based filtering, and the problem is security challenge. And the security challenge because the broker is aware of what is the content of that message. So basically these content based filtering is used where the security is not a concern. So next is the type based filtering, and in the type based filtering we used a different program to filter these messages. Let me add. I think someone wants to join. I don't know who wants to join. Oh, sorry. Next is we will talk about the connection establishment. How connection is established, right? So up till this point, if you have any doubt, please ask. Okay, I hope there is no doubt. Okay, fair enough. So we will talk about MQTT client establishment, or the connection establishment to be more specific. Any client, whether it is a publisher or a subscriber, right? Any client, whether it is a publisher or a subscriber, first send a connect request to the broker. Just see. It sends a connect request to the broker, And if a broker agrees for the connection, it will send a connect message, that is connection acknowledgement message. So what happens, the publisher, either the subscriber, send a connect request, connect message to the broker. It sends to the broker, and then broker acknowledge the to subscriber with connect. Right. Next, okay, okay. So this is how MQTT platform looks. We will also going to see these things. So there, if you see here, sorry, at mine there is a power failure. So I hope now I'm audible, right? Someone please reply that I'm audible or not. Okay, thank you very much. Okay, fair enough. So this here, I hope the PPT is visible. So here we can see one of the uh, MQTT. So here we can name the client, right? Let us say I'll name FDP1. Here is the host, and this host is nothing but a broker, right? Here we can put a username, ABCD, and here I can put a password 1234. It is not always required, but when you are sending your private data, you need to have the username as well as the password. These are the this is the client ID, right? So most of the software which is used for MQTTs, generally they generate their client ID, which is unique on that subscriber. So this is will topic. This is quality of service. We will talk later on what is the quality of service, and all those things are I mean, these are the things. So what we need to focus is when you try to connect with any of the broker, we must need to have a client name as well as a client ID and a host. Host is nothing but a broker. So when you click on joining this client will ask this broker with a connect message, and this connect message will have a client name, client ID, and it may contains the username and the password also. We can specify the quality of service, we can specify the will message, right? So this is the structure of MQTT client. Next is, so what the connect message has, the connect message that is sent by the broker to the client in the response of connection request, right? Sorry. So it the connect message has two flag, session flag and a connection acknowledgement flag, right? So what session flag has, the session flag tells us if it is true, that indicates there is a presence of session from the previous connection, right? This means true means there is a session present from previous connection, and if it is false, then they will establish a new session, right? Okay, now if you see over here, the client requested a new session, that is clean session, that it needs to start a new session, right? So then for this response, the broker will send session flag false, right? I hope it is understood. Next is the connection acknowledgement flag, and connection acknowledgement flag tells us whether this connection is successful or not. So we'll see what is the uh, connection acknowledgement flag. So if it returns zero, that means connection is successful. If it returns one, that means connection is refused, and this is refused due to the protocol, right? If it is two, the connection is refused because the broker is not able to identify the client. When it returns three, that means connection is refused, and this is refused because of server unavailability. When it returns four, connection is also refused in this case, but it is due to refused when there is username and the password mismatch. And when it returns five, again the connection is refused, but the connection this time refused due to the authorization purpose, because this client may not be authorized to connect to that particular broker. So to summarize it, the return could be either 0 or 1 to 5. So for 0, connection is established. Here connection is refused, and there are various reasons for the refuse. The first one is the protocol mismatch, the second one is identity mismatch, the third one is the server is not available, fourth one user name and password mismatch, and the fifth one is the this client is not authorized to connect to the particular server, right? So these are the, so here we can see what connect respond, what connect message sent, and with the return code, and what does the return code means. If you have any doubt up till this point, I hope no. Okay, no issue. Next, we'll talk about how to publish it and how to subscribe it. Right. So what happened? When for a client, when it publishes, it must specify the topic, the quality of the service, a return flag, and payload type and the payload. We will see the figure or the structure how the client is published. For the subscription, again, here we talk about the publishing. So when a client is publishing anything, it must identify the topic, quality of service, return flag. Next one is the payload type and payload. When we do the exercise, these all those things will be pretty much clear, right? Now we'll talk about the subscription. So for a subscription, the client identify which topic and what are the quality of service it wants to subscribe. So for the subscription, it must identify the topic as well as the quality of service. Okay. And once it's subscribed, broker sends a sub-act message. Broker send a sub-act message, and what are the sub-act contains? The sub-act contains a return code which specified a topic and the quality of service pair. So we'll just see if return code is 0, right? So you have successfully subscribed that topic with quality of service 0. If return code is 1, you have successfully subscribed that service or topic with quality of service 1. When the return code is 2, you have successfully subscribed it with quality of service 2. And if it return 1 to 8, that represent your subscription is not completed, the subscription is failed. Next we'll see, so at the time of publishing, what a publisher need to have: the packet ID, let us say example 4314. So this packet ID is necessary because from a source to the destination there may be various paths, right? Of course it will go through the broker. Here I'm just saying, okay, don't be confused. I'll say discard it. So what I'm saying is there is a source and there is destination. So the source is a client and destination is a broker. So there may exist various paths, right, to the reach to the destination. So this packet ID is essential when broker identify which packet it got. Then we will have topic name, which is always necessary. Then we can have the quality of service, return flag, payload. What is the exact payload? Like here we are sending the temperature data, so it is temperature 32.5. This is the actual payload. And the flag. The flag is represent this DUP flag. It is either false or true. False represent it is a new message, and true represent it is a duplicate message. And why it is a duplicate message? Because once the publisher sent this message, once a publisher sent to this message to broker, it does not got any acknowledgement. That's why it starts sending the same message with dup flag on. Someone wants to join. Let me enter it. Next is the subscribe. So what subscriber contains? One is the packet ID, and then the pair of quality of service and topics. So a subscriber can subscribe many topics. Like here, each subscribe quality of service 1 topic 1, quality of service topic 2, and so on. Right? This is the one of the software screenshot for the subscription. I'll also tell us about what are these meanings. And then the last portion is unsubscribe. So what happened? To unsubscribe any topic, the unsubscribe message is sent to the broker from the client that I want to either unsubscribe this particular topic or the list of topics. So the unsubscribe message consists of packet ID and the topics. Right? So it will consist of packet ID and topics. The broker send a unsubback, that is nothing but an acknowledgement, and this acknowledgement consists of a packet ID. Right? So once it sent unsub back, that means the client is already unsubscribed to that particular topic. These are the references I have used. Okay, but believe me, you can find a lot of references over there. Okay, if you have any doubt, we can discuss here. My video is not on because now I'm running with the metered connection with my phone, so that's why my video is not on. Otherwise, I'll be able to take you all of your questions. So I request you to please go through. Okay, identity and authorized difference. Okay, so in this case, the first one is a subscriber does not identify itself, right? Sorry. Okay. So does not identify itself. Authorization difference means a subscriber identifies itself, but it is not authorized to join or to connect this particular broker. Next, our message is stored on the broker. Of course, message can be stored at the broker. There is no problem at all. Message can be stored at the broker, but mostly brokers which is available right now, that does not store the message. But still, there is a provision you can store the message at the broker. Uh, any more questions? Okay, so we will do a small exercise. Maybe so. I request 5 volunteers. If you have phone, okay. So what we'll do? Uh, okay. So if I need some of the volunteers which is having laptops, or maybe, okay. So I need volunteers which is having laptops or either phone. So let us say, okay, let us say 2 laptops or 2 desktop or three phones. Okay. So what we'll do? I request you to install in your phone. Okay. I request you to please install in your phone MQTT client, any one of the MQTT client. Still my voice is breaking. Okay, no issues. So let me, okay, give me some time. I try to. I hope my voice is clear now. Okay, fair enough. So if someone of can join, I mean, install MQTT client. So those volunteers can switch on their mic. Uh, I request volunteer to switch on your mic.
My MQT is installed in my mobile. Yes, sir. This is Vignesh.
So I can see 2 volunteers over there. I hope I'm audible, right?
करो मेल तो करो डेमो माटे
And those who are having laptops, they can install.
Hello.
Can you? Hello. Yes. Please do it.
Yes, sir. My MQT is installed in my mobile. My
Okay.
MQT.
No issue. Uh, So those who are having laptop or desktop, they can install MQTT box. MQTT box. Okay, what I'll do,
Can I use MQTT online?
I hope this MQTT box is visible.
Yes, sir. It's visible.
Okay. Okay. So now what we do, we create a client. So just see what we do. We create a client. Now you just see here is the provision of a client name. So I'll just name FDP1, right? And this is the host, iot.eclipse.org. This is the host, and now I'm saving this. So now I have saved it either from this client. Okay, there is a connection here. Uh, at my end, there is a slight internet problem. Give me some time. I think there is a slight internet problem. Uh, I'm really sorry because my internet is poor. I'm connected with my phone because there is a power problem. So what I do, I'll I'll complete this exercise maybe in some other time, right?